अस्सलामुअलैकुम डियर स्टूडेंट्स। आज हम 11th क्लास की फ़िज़िक्स के ऐसे 50 शॉर्ट क्वेश्चंस और आंसर्स पढ़ेंगे जो कि बोर्ड्स के पेपर्स में हर साल मुसलसल आ रहे हैं। आपको भी काफ़ी हद तक इन्हीं सवालात में से शॉर्ट क्वेश्चंस आएंगे, इसलिए इन तमाम सवालात को अच्छी तरह याद। डिफाइन पॉजिटिव एंड नेगेटिव टॉर्क्स। एंटी क्लॉकवाइज टॉर्क इज taken as positive. Clockwise torque is taken as negative. What is ballistic missile? Define its trajectory. Oh, what is a ballistic missile and ballistic trajectory? An unpowered and unguided missile is called a ballistic missile. The path followed by the ballistic missile is called ballistic trajectory. Define null vector. A vector with zero magnitude but certain direction is known as a null vector. Why a null vector cannot be added to zero? Explain. Null vector is a vector with zero magnitude and arbitrary direction. We cannot add a scalar number, even if it is zero, to a vector quantity. Define torque and moment arm. Turning effect of force on a body about the axis of rotation is called torque. The formula of torque is T is equal to radius into force. The distance between pivot point and applied force is called moment arm. When rocket re-enters the atmosphere, its nose becomes very hot. Why? When rocket re-enters the atmosphere, its nose becomes very hot. This heat is produced because of the friction of rocket with air particles. Define centripetal force and write its formula. The force needed to bend the normally straight path of the particle into a circular path is called the centripetal force. Its formula is Fc is equal to mv square over r, where m is equal to mass, v is equal to velocity, and r is radius of circular path. What is meant by angular momentum? State law of conservation of angular momentum. Angular momentum is the cross product of position vector and linear momentum. Its formula is L is equal to R into P. Law of conservation of momentum. The axis of rotation of an object will not change its orientation unless an external torque causes to do so. This is law of conservation of angular momentum. An object has 1 joule potential energy. What does it mean? Explain. If an object has 1 joule potential energy, then it means that it has the capacity of doing 1 joule work. Gravitational potential energy. 1 joule potential energy means that object has the capacity to do 1 joule work when falling freely. Elastic potential energy. 1 joule of elastic potential energy means that object has the capacity to do 1 joule work when a compressed or stretched spring is released. Write 2 conditions for which torque is 0. If no force is acting on a body and it is at rest, then its torque is 0. If body is rotating with uniform angular velocity, the angular acceleration will be 0. In this case, torque will be 0. Define equal vectors. 2 vectors A and B are said to be equal if they have the same magnitude and direction regardless of the position of their initial points. Parallel vectors of the same magnitude are equal to each other. Is it possible to add a vector quantity to a scalar quantity? Explain. It is not possible to add a vector quantity to a scalar quantity. A vector quantity contains magnitude and direction, while a scalar quantity has only magnitude and no direction. That's why a vector quantity cannot be added into a scalar quantity. What is impulse? Show that impulse and momentum have same unit. When a force acts on a body for a very short time, the product of the force and the time for which the force acts is called impulse. Mathematical form of impulse or formula of impulse is I is equal to force into time. Unit of impulse is Newton second or kilogram meter per second. Unit of momentum is kilogram meter per second. It can also be expressed as Newton second. At what point or points in the path does a projectile have its minimum speed and its maximum speed? The speed of projectile is minimum at the maximum height because the vertical component is 0 at the maximum height. The speed of a projectile is maximum at the point of projection and also just before it strikes the ground, level of projection, because the vertical component of velocity is maximum at these points. What is meant by projectile motion? Write range of the projectile. A two-dimensional motion in which an object is moving under the action of gravity and making a certain angle with horizontal is called projectile motion. Maximum distance which a projectile covers in horizontal direction is called the range of the projectile. Its equation is R is equal to Vi square sine 2 theta over G. Show that range of projectile is maximum when projectile is thrown at an angle of 45 degrees with horizontal. As we know that range of projectile is equal to Vi square sine 2 theta over G. For the range R to be maximum, the factor sine 2 theta should have maximum value which is 1. So here sine 2 theta is equal to 1, whereas 2 theta will be equal to sine inverse 1. 2 theta is equal to sine inverse 1 is equal to 90 degrees. So theta will be equal to 45 degrees. Calculate the work done in kilojoules in lifting a mass of 10 kilograms through a vertical height of 10 meters. What is given here? Mass is equal to 10 kg, height is equal to 10 meters, gravity is, as we know, 9.8 meters per second square, and we have to find work done. As we know that work done is equal to potential energy. W is equal to M into G into H. By putting values, M is 10, G is 9.8, H is 10. W is equal to 980 joules. अब हमने इन जूल्स को किलो जूल्स में क्योंकि तब्दील करना है, इसलिए हम 980 को 1000 से डिवाइड करेंगे ताकि हमारे पास किलो जूल्स आ जाए. So we have the value W is equal to 0.98 kilojoules. Define kilowatt hour. shows that 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. The kilowatt hour is the work done in 1 hour by an agency whose power is 1 kilowatt. Mathematical relation. We know that 1 kilowatt is equal to 1000 watts and 1 hour is equal to 3600 seconds. So 1 kilowatt hour is equal to 1000 into 3600 seconds, which is equal to 3600,000 watts second, which is equal to 3.6 into 10 power 6 joules. Define angular velocity. What is its SI unit? Angular velocity is defined as the rate at which the angular displacement is changing with time. It is denoted by omega. Mathematically, W is equal to d theta over dt. Its SI unit is radian per second. Why does a diver change his body positions before and after diving in the pool? A diver changes his body positions before and after diving to increase his angular velocity. We know that V is equal to R into omega, which implies that angular velocity is inversely proportional to radius. Angular velocity omega increases as the radius of a body decreases, because both of these quantities have inverse relation. A diver reduces radius of his body by bringing close his arms and legs. This allows him to perform more flips before entering the water. What is meant by moment of inertia? Give its significance. A quantity that decides the amount of torque needed for a specific angular acceleration in a rotational axis is called moment of inertia. Moment of inertia is also known as the angular mass or rotational inertia. यानी इसके दो नाम ये भी हैं, ये भी याद रखिएगा. It is a scalar quantity and it is denoted by I. Its formula is I is equal to mr square. The SI unit of moment of inertia is kilogram meter square. Significance. The moment of inertia plays the same role in angular motion as the mass in linear motion. जिस तरह linear motion में mass का किरदार है, इसी तरह moment of inertia का angular motion के अंदर किरदार होता है. Define viscosity. Viscosity is the frictional effect between layers of a flowing fluid. Viscosity measures how much force is required to slide one layer of fluid over another layer. Substances that are thick have large coefficient of viscosity and vice versa. SI unit of viscosity is Newton second per meter square or kilogram per meter second. Example, thick liquids like honey and oil are more viscous, while thin liquids like water have small viscosity. Why fog droplets appear to be suspended in air? A tiny fog droplet has a very small weight. As the droplet of fog drops, the drag force acting on it becomes equal to the weight of droplet. Thus, the net force acting on the droplet becomes zero. Thus, droplet will fall with terminal velocity or constant speed whose value is very small. Therefore, the droplet falls so slowly that it appears or it seems to be suspended in the air. Explain the difference between laminar flow and turbulent flow. Laminar flow. The flow is said to be streamline or laminar if every particle that passes a particular point moves along exactly the same path as followed by particles which passed that point earlier. Example, blood through capillaries has laminar flow. Turbulent flow. The irregular or unsteady flow of the fluid is called turbulent flow. Example, flow of oil in pipelines and flow of honey are two examples of turbulent flow. Two rowboats moving parallel in the same direction are pulled towards each other. Explain. According to Bernoulli's theorem for horizontal flow, P plus 1 over 2 PV square is equal to constant. When velocity of liquid flow increases, the pressure decreases. Therefore, the pressure exerted by water in between the boats becomes less than the pressure of water outside the boats. Due to this pressure difference, both the boats which are moving parallel in the same direction are pulled towards each other. Explain how the swing is produced in a fast moving cricket ball. When cricket ball is bowled by the fast bowler, the velocity of air on one side, shined one of ball, increases due to less friction. According to Bernoulli's equation, when velocity is high, then pressure is low, and ball moves in curved shaped path toward the shined side, which is called swing. What is Stokes' law? Explain briefly. For a spherical body of radius r moving slowly with velocity v in fluid of viscosity eta, the drag force on the spherical body is given by the following formula. F is equal to 6 pi eta r. This equation is called Stokes' law. Does the acceleration of a simple harmonic oscillator remain constant during its motion? Is the acceleration ever zero? Explain briefly. No, acceleration of simple harmonic motion does not remain constant. Acceleration becomes zero at mean position. The acceleration at any instant of a body executing simple harmonic motion is proportional to displacement and is always directed towards its mean position. When displacement becomes zero, acceleration becomes zero. That is, at mean position, there is zero acceleration. What is meant by phase angle? The angle theta is equal to omega into t, which specifies the displacement as well as the direction of motion of the point executing simple harmonic motion, is called phase angle. Describe two common phenomena in which resonance plays an important role. Number 1. Swing. A swing is a good example of mechanical resonance. It is like a pendulum with a single natural frequency depending on its length. If a series of regular pushes are given to the swing, its motion can be built up enormously. Number 2. Tuning of radio. Tuning a radio is another example of electrical resonance. When we turn the knob of a radio to tune a station, we are changing the natural frequency of the electric circuit of the receiver to make it equal to the transmission frequency of the radio station. When two frequencies match, energy absorption is maximum, and this is the only station we hear. If a mass spring system is hung vertically and set into oscillations, why does the motion eventually stop? If a mass spring system is hung vertically and set into oscillations, its motion eventually stops due to damping effect. This damping effect is due to air resistance, friction, and gravity factors. The mechanical energy of the system is wasted into heat due to the resistive forces. Such oscillator can be called as damped harmonic oscillator. Why sound travels faster in warm air than in cold air? Explain. The speed of sound in air is given by V is equal to square root of gamma into P over rho. This relation shows that speed is inversely proportional to the density. That is, V is inversely proportional to the square root of 1 over rho or density. It means greater the density, smaller the speed of sound. The density decreases with rise in temperature. In case of warm air, since temperature is greater, so the density is smaller. Hence, the speed of sound increases. In the case of cold air, since the temperature is smaller, so the density is greater. Hence, the speed of sound decreases. Why does sound travel faster in solids than in gases? We know that V is equal to square root of E over rho or density, where E is equal to elastic modulus and rho is equal to density. Speed of sound is greater in solids because the value of elastic modulus E is greater for solids than other states, and molecules in a solid are closer than in gas and hence respond more quickly to a disturbance. Is it possible for two identical waves traveling in the same direction along a string to give rise to a stationary wave? Explain briefly. No, it is not possible for two identical waves traveling in the same direction along a string to give rise to a stationary waves. Stationary waves are produced only when two waves of equal frequency travel in opposite direction along a string. Define beats and give two uses of it. Two waves of slightly different frequencies and traveling in the same direction superpose to give rise to a note of alternately increasing and decreasing intensity. Such a sound is called beat. Uses. Number 1. Beats are used in tuning a new musical string instrument. Number 2. Beats are used to find the unknown frequencies. How are beats useful in tuning a musical instrument? Musicians can use beats to tune a string instrument such as a piano or violin by beating a note against a note of known frequency. The string can then be adjusted to the desired frequency by tightening or loosening it until no beats are heard. What is meant by wave front? Give its types. Wave fronts. Such an imaginary surface on which all the points have the same phase vibration is known as wave front. There are three types of it: plane wave front, cylindrical wave front, spherical wave front. State Huygens principle. Huygens principle consists of two parts. Number 1. Every point of a wave front may be considered as a source of secondary wavelets which spread out in forward direction with a speed equal to the speed of propagation of the wave. Number 2. The new position of the wave front after a certain interval of time can be found by constructing a surface that touches all the secondary wavelets. Under what conditions two or more sources of light behave as coherent sources? Under following two conditions, two or more light sources behave as coherent. Number 1. Two or more sources of light derived from a single source of light behave as coherent source. Number 2. A source and its virtual image behave as two coherent sources. Can visible light produce interference fringes? Explain. Yes, white or visible light can produce interference fringes. Visible light is composed of 7 colors. By passing through slits, it would simply split into 7 different waves. These waves would interfere with each other, producing maxima and minima of a screen. But each wave will interfere with other wave of the same wavelength. Why central spot of Newton's rings is dark? At the point of contact of the lens and the glass plate, the thickness of the film is effectively zero. But due to reflection at the lower surface of air film from denser medium, an additional path difference of lambda over 2 is introduced. Consequently, the center of Newton's rings is dark due to destructive interference. How would you manage to get more orders of spectra using a diffraction grating? For diffraction grating, we have equation d sine theta is equal to n into lambda, which implies that d is directly proportional to n. Where d is the grating element, it is the distance between two adjacent slits on a diffraction grating. If we want to increase orders of spectra n from 0 degrees to 90 degrees, we have to increase d. It means that there should be less number of slits on a diffraction grating. Grating element d is equal to L over n, where L is length of diffraction grating and n is the number of lines on it. Can you obtain Newton's rings with transmitted light? If yes, would the pattern be different from that obtained with reflected light? Yes, Newton's rings can be obtained with transmitted light. In case of transmitted light, the fringe pattern is just opposite to the reflected pattern because of no phase change of 180 degrees. It means that the center spot of Newton's rings in this case will be bright instead of dark due to the transmitted light. If a person was looking through a telescope at the full moon, how would the appearance of the moon be changed by covering half of the objective lens? If half of the objective lens of a telescope is covered, the moon will appear full to the person looking at it, but the intensity of light depends upon the diameter of the object lens. Therefore, the intensity of the light received from the moon will decrease. Thus, its brightness is reduced by the half-covered objective lens. Define isothermal and adiabatic processes. Isothermal process is a process which is carried out at constant temperature and hence the condition for the application of Boyle's law on the gas is fulfilled. An adiabatic process is the one in which no heat enters or leaves the system. Examples: the rapid escape of air from a burst type and cloud formation in the atmosphere. Why would it be advantageous to use blue light with a compound microscope? It would be advantageous to use blue light with a compound microscope because the blue light of short wavelength produces less diffraction and allows to see the more details of the object. Is it possible to convert internal energy into mechanical energy? Explain with an example. Yes, it is possible to convert internal energy into mechanical energy. In adiabatic expansion, internal energy is converted into mechanical energy. According to first law of thermodynamics, Q is equal to delta U plus W. In adiabatic process, heat of the system remains constant. That is, Q is always 0. Thus, W is equal to minus delta U. This relation shows that gas expands and does external work. It is done at the expense of internal energy of its molecules, that is, converting into mechanical energy. Example: heat engines are the example of a process in which internal energy is converted into mechanical energy. Explain the difference between tangential velocity and the angular velocity. Write the formula related to them. Tangential velocity. It is linear velocity of a particle moving along a circle or curve. Formula of tangential velocity is Vt is equal to omega into r. Vt is tangential velocity, omega is equal to angular velocity, and r is radius of wheel. Unit of tangential velocity is meter per second, and direction of tangential velocity at any given point on the circle is always along the tangent to that point. Now we come to angular velocity. Angular velocity is defined as the rate at which the angular displacement is changing with time. Angular velocity is denoted by omega, and its formula is angular velocity is equal to d theta over dt. Unit of angular velocity is radian per second. The direction of angular velocity is represented by a line drawn parallel to the axis of rotation. Define work energy principle. Also write down its equation. Work done on the body equals the change in its kinetic energy. This is called work energy principle. Mathematical derivation. We know that equation of motion is 2AD is equal to Vf square minus Vi square, which implies that d is equal to 1 over 2a into Vf square minus Vi square. Let us suppose this is equation number 1. We also know that second law of motion is F is equal to ma. Suppose this is equation number 2. Now we multiply both these equations. So on the left side we have F into d equals ma into 1 over 2a Vf square minus Vi square. Now we know that W is equal to F into d, so we replace F into d with W, और इधर ये वाला ए और ये वाला ए आपस में कट गया, तो ये आ गया 1 over 2 इंटू एम इंटू वी एफ स्क्वेयर माइनस वी आई स्क्वेयर. अब हम m को ब्रैकेट के अंदर मल्टीप्लाई करते हैं, तो ये आ जाएगा हमारे पास W इज इक्वल टू 1 over 2 एम वी एफ स्क्वेयर माइनस 1 over 2 एम वी आई स्क्वेयर. काइनेटिक एनर्जी फाइनल इज इक्वल टू 1 over 2 एम वी एफ स्क्वेयर, whereas kinetic energy initial is equal to 1 over 2 mvi square. So we replace both these quantities with KEF and KEI. So W is equal to kinetic energy final minus kinetic energy at its initial position. Now the difference of both these energies will be equal to delta kinetic energy. What is the difference between elastic collision and inelastic collision? Also give examples. Elastic collision. The total kinetic energy is conserved. Momentum does not change. No conversion of energy takes place. Highly unlikely in the real world, as there is almost always a change in energy. An example of elastic collision can be swinging balls or a spacecraft flying near a planet but not getting affected by its gravity in the end. In elastic collision, the total kinetic energy of the bodies at the beginning and the end of the collision is different. Momentum changes. Kinetic energy is changed into other energy such as sound or heat energy. This is the normal form of collision in the real world. An example of an inelastic collision can be the collision of two cars. What is the difference between precision and accuracy? Precision. Precision means how close the results are with each other. Precision measures how well measurements can be reproduced. Precision does not take into account the accepted values. It is concerned with random error. Accuracy. Accuracy means how close the results are to the actual value. Accuracy is the measure of quantity to reality. Accuracy takes into account the accepted value. It is concerned with a systematic error.